Okay, hello again. So we are exploring how material gets in and out of a cell across the cell membrane. So we've been talking about diffusion. Let me get my pen here. We were talking about how the membrane transportation can be categorized in several different ways. One is passive and active transportation. So passive is no energy is needed for the process, whereas active energy is needed. The other way is whether a protein is used in the process or not. Okay, so let's take a look at osmosis. What is osmosis? First, let's go ahead and put a definition of osmosis. So it is diffusion of water across a semi-permeable membrane. Okay, so according to the concentration gradient, so just like diffusion, we talked about diffusion before and how a solute will go, in diffusion, will go from an area of high concentration to an area of low concentration. In this case, though, in osmosis, we're talking about water. Instead of the movement of water, or excuse me, instead of the movement of solutes, we're talking about the movement of water. And in diffusion before, we were saying that it didn't need a membrane. You know, we could have diffusion just through the air. We can have perfume through the air. We can have sugar in our tea. But in the case of osmosis, you need a semi-permeable membrane. Okay, so what does that mean? Let's take a look. So this is an experiment, and we have a bag right here. And this bag is made up of a semi-permeable membrane. Oops, that's a B. Membrane. Okay, and this bag is full of sugar water. The beaker that you have the bag in, this is all water. This is sugar water, okay, inside the bag. Okay, so what do I mean by semi-permeable? It means that there are very small holes in this bag, which will allow a small molecule like water to get through, but so small that a glucose molecule can't get through. Now remember, water molecule, H2O, 3 atoms. A glucose molecule is getting ahead of myself, C6H12O6. That is a big molecule, and it cannot get through. So what's going to happen? We put this bag of sugar water here in this beaker of water. Well, the water can get through, but the glucose or sugar molecules can't get through. So, so you have some glucose molecules in here. Remember we talked about that, how that dissolves, the glucose dissolves in water, because water molecules are polar and the sugar molecule is polar. So they surround the glucose molecule, attach to it with hydrogen bonds, and that means that those water molecules are now being taken up. So you, by putting sugar into that water, and the water gets used to surround the glucose molecules, the water concentration actually decreases. So I'm going to use brackets right here to stand for the water concentration. So inside the glucose water, the water concentration is decreased compared with the water concentration out here, because the water is being used to bond to these glucose molecules. But our glucose solution, so we've got a glucose solution inside, the glucose concentration is extremely high. And what do you think? Our glucose concentration is extremely low. So glucose concentration is low out here. Okay, so remember diffusion. It's the movement of molecules from an area of high concentration to an area of low concentration. So we have water out here has a high concentration of water and a lower concentration of water on the inside. So which direction's our water going to go? The water is going to go from an area of high concentration to an area of low concentration. And that's what's happening here. So over time, that water is going to move from the beaker on the outside inside, which is going to push this whole solution up into the bag because the amount of solution is increasing. It's taking water from out here and pushing it in here. And then over time, more water gets brought inside to equal out that concentration of water, and so pushes up the amount of solution. Get my pen again. Here we go. Okay, so that is osmosis, the movement of water from an area of high concentration to an area of low concentration. But if you think about it though, the water is moving from an area of low concentration of solute to a high concentration of solute. So you have to think of it as the movement of the water. Okay, so what does it have to do with cells? Well, let's take a look. Okay, one example where it comes into play are red blood cells. So these are red blood cells. Okay, and we want to have a term. Let's go ahead and define a few terms here. So tonicity describes the amount of solute in the cell compared with the amount of solute outside of the cell. Okay, and how does that have to do with osmosis? Okay, so let's change the color here. How about okay, we've got a solute. Let's take this middle example right here, these red blood cells. So we have a solute out here in the extracellular fluid. Let's say this is salt. These are sodium and chloride ions out here. We also have some salt inside the cells. So we have the salt inside the cells as well. And there's water in here as well. Let's get a watercolor. Okay, we also have water out here as well. So let's say that those concentrations are about the same. So the water concentration is about equal inside and out. Solute concentration is equal inside and out. So this is called isotonic. Okay, but what happens if you increase the solute particles? Let's say you increase the solute particles. What did we use? What color did we use? We used orange. So let's say we increase the solute particles out here. Then what happens? We have a higher solute concentration on the outside, a lower on the inside. But what about our water? Remember, osmosis had to do with water. So we now have a higher concentration of water on the, compared with the solute particles on the inside than outside. So remember, these water molecules are surrounding these ions, and so you end up getting on each side. So the water is surrounding each of these. So you end up using more water out here because you've increased the solute. So you end up using a lot of those water molecules to surround more of these solute particles. So you end up getting a lower concentration of water. Let's try that again. Color, let's do our blue. Okay, so you've got a lower concentration of water outside and a higher concentration of water inside. So water is going to move from high concentration of water on the inside, H2O, to a lower concentration outside. So water is actually going to flow out of the cell, and it's going to shrivel the cell. That is called hypertonic. Oops, oh, I need a Y in there. H-Y, tonic. So the solution on the outside is hypertonic to the solution on the inside. Okay, what if the opposite were to happen? Let's say we used distilled water outside of these blood cells, so that there's barely any salt particles on the outside at all. But remember, there's water on the inside, but there's some salt in cells. So we have a higher concentration on the outside than on the inside. Water's going to flow in and burst the cells. That is called hypotonic. So the solution on the outside, higher concentration than on the inside. Okay, and that's osmosis and tonicity. I hope you found that interesting.